This topic is related to refraction, connecting the idea of actual depth, apparent depth, how it's related to the refractive index of the denser and rarer medium, and how much the object feeling to be shifted due to refraction. Here the blue color region represents a denser medium. O is a point or point object which is at the bottom of the denser medium. If a person standing in the rarer medium and observing this particular point, how he is feeling the position of the point O, or how the bottom of the denser medium is appearing for him. The denser medium can be like a glass slab or water like a swimming pool. For image formation, minimum we need two light rays. One light ray from O go along the normal without any refraction, comes out of A straight. Another light ray incident at B. Since the light ray is moving from denser to rarer medium, bend away from the normal. Instead of going straight, light ray bend away from the normal. I is the angle of incidence and R angle of refraction, both with respect to the normal to the refracted light ray and normal to the incident light ray. Using mathematical properties, angle of refraction is same as the angle formed at I, corresponding angles, because this light ray coming out of A and the normal at B both are parallel. This is a transversal cutting those two parallel light rays. The angles at same position are corresponding angles. This angle of incidence I is same as the angle formed at I, that's due to alternate interior angle property. Now, for finding the image, since the light rays are diverging after refraction, to locate the image, the light rays has to be extended back. So this refracted light is extended straight back, that meet with the light ray out of A extended backwards. So both are meeting at I. I is the image point corresponding to the object point O. Means what is at O is feeling to be at I for a person standing outside the denser medium and observing the point O. The depth, actual depth from A to O will be just feeling like only A to I. Means the object at O, which is the bottom, that is feeling to be shifted to I. The complete bottom of the denser medium is shifted to I. So instead of feeling the actual depth A to O, the person will feel only the depth to be AI, which is called apparent depth. AI is the apparent depth, what he feels, but AO is the actual depth. The shift, the object at O is feeling to be shifted to I. So O to I is called the shift. So the details, A to O is actual depth, which is marked as T. A to I is the feeling, that is the apparent depth. The shift is from O to I. Now the relation connecting apparent depth AI, actual depth AO, and the shift OI. Actual depth AO equal to apparent depth AI plus shift OI, or shift OI equal to actual depth AO minus apparent depth AI, or apparent depth AI equal to actual depth AO minus shift OI. Any one, all the three can be obtained from this particular formula. Apparent depth equal to apparent depth AI equal to actual depth AO minus shift. Applying Snell's law for finding the relation, sin I by sin R equal to N2 by N1. Here N2 is the rarer medium, N1 is a denser medium, because light is moving from denser medium to rarer medium. Sin I and sin R we can find from these triangles. For sin I, triangle OAB, sin I is opposite side AB by hypotenuse OB. So sin I equal to AB by OB. From triangle IAB, sin R equal to opposite side AB by hypotenuse IB. So AB by IB equal to sin R. When you divide sin I by sin R, AB common get cancelled. Denominator will go up. So IB by OB. Sin I by sin R equal to IB by OB. Now for a person to see this particular point as image, the light ray coming out of A and light ray coming out of B both has to be reaching the same person's eye. For that, the point B has to be very close to O. Means the observer standing here will receive the light ray only if the light ray refracting out of B, that is close to A. So A and B are actually very close points for a near normal vision. A person standing near the normal will receive both the light rays only if the point B is very close to A. Meaning O to B distance can be approximated as OA, I to B distance can be approximated as IA. So IB will become IA, OB will become OA. So sin A by sin R equal to IA by OA. This is only for the near normal vision, for a person standing very close to the normal. Now for finding the relation, we need to substitute IA by OA, sin A by sin R, which is N2 by N1. So N2 is rarer medium, so NR by ND. So IA by OA equal to NR by ND instead of N2 by N1. So NR by ND equal to IA by OA. IA is apparent depth, OA is actual depth. So NR by ND equal to actual depth by apparent depth. This is a relation for apparent depth, actual depth in relation to refractive index of denser medium and rarer medium. For finding the shift O to I is the actual depth AO minus apparent depth AI. So O to A minus I to A. For simplified relation, OA you can take out. So multiplying OA up and down with IA into OA by OA. So OA will common out. 1 minus OA will go out IA by OA. So OA gone out common, 1 is left here. You multiply OA up and down. Numerator OA will go out common. So numerator OA will remain. We substitute the values. O to A is P. IA by OA is equal to apparent depth by actual depth 1 NR by ND. Now if the second medium is higher, NR will be 1 or refractiveness 1. So S equal to T into 1 minus 1 by N. This concept is just applied in one formula for questions, like it's a sample, how this formula can be used. Here another case, if there are multiple media like glass, water, kerosene, different oils, so different layer of media, the total shift can be calculated as shift of light ray in one medium, assuming second medium to be air, shift in the second medium, assuming air to be second medium for that. Like you can add the shift of each media, assuming second medium of that particular case to be air. S1 is calculated with second medium as air. S2 is also calculated as second medium as air, and adding all the shifts with the total shift. The sample question. Here three different liquids, density D1, D2, D3. D1 is greater, will be a bottom. D2 intermediate, D3 on the top. The refractive indices are mu1, mu2, mu3. They are kept in a beaker together. The height of each liquid column is x by 3. So the total height of the medium together will be 3 times x by 3. A dot is made at the bottom of the beaker. For normal or near normal vision, find the apparent depth of the dot. So shift is actual depth minus apparent depth. Apparent depth will be equal to actual depth minus shift. Actual depth we already have. Actual depth of the entire media is h by 3 into 3, 3 times of h by 3. For finding the shift, you need to find s1, s2, s3 and add all the shifts together. So for s1, the thickness will be h by 3 because each medium is h by 3. 1 minus, assuming second medium to be higher, 1 by ND. ND is mu. So s1 equal to h by 3 into 1 minus 1 by mu. Or similar to that, s2 will be same thickness h by 3 into 1 minus 1 by mu2 will come instead of mu1. Similar to that, s3 will be same thickness h by 3 1 minus 1 by mu3 instead of mu2. The total shift we can simply add all the three. H by 3 with 1 minus 1 by mu1, simply all the three cases. You can take h by 3 common out. If we take h by 3 common out, so 1 plus 1 plus 1 3. So 3 minus 1 by mu1 minus 1 by mu2 minus 1 by mu2. Now for the apparent depth, we use actual depth minus shift. The actual depth, the total actual depth is h by 3 for each media into 3 minus the shift is h by 3, then we say common out, it will be 1 plus 1 plus 1 3, then 1 minus mu1 minus 1 minus mu2 1 minus mu2. Now here h by 3 is common, h by 3 can be taken out common. When h by 3 go common out, 3 minus bracket 3 minus 1 by mu1 minus 1 by mu2 minus 1 by mu2. Now you open this bracket, minus of 3 will be minus 3, this minus will be making all 1 by mu1, 1 by mu2, 1 by mu3 is plus. So 3 minus 3 get cancelled. So h by 3 common out, 3 minus 3 will go, then 1 by mu1 plus 1 by mu2 plus 1 by mu2. Let's see the final answer. The apparent depth is h by 3 into 1 by mu1 plus 1 by mu2 plus 1 by mu2. There is one more bracket. This is the second bracket, first bracket. That's a relation when there are multiple media comes, how the different refractive indices are related to the apparent depth or the shift.